start with my apologies. The last part of the talk today is going to be using tech, and from many years of experience in classrooms, it always fails in classrooms. So we'll do the best that we can.
Apologize ahead of time.
You'll see it exactly. Right. Pre-apologies always work out really well. So I'll have to look at the slide to see what look backwards to see what I'm talking about. I use this term. You guys have heard the term Internet of Things, right? And really, the idea of classroom of things is sort of my play on that. The idea that, I had some pictures I get rid of them, but I remember the poor Enrique. I'll try to stay still. I remember, the days when I was going to school in elementary school. The big technologies were things like, besides mechanical technologies like chalkboards and things, was the opaque projector. Okay, where you slid a book underneath there, or slide strips, and then the cool revelation of the transparency projector, but mostly things that were about sort of one-to-many technologies, ways that teachers could project out into space for our kids. And the revolution that I saw, not so much when I was in school, but when my kids were in school, was moving to individual technologies, in particular the calculator. Okay, and the way that changed things and distributed responsibility away from strictly the teacher into the hands of everybody, but also, of course, multiplied the problems with potential breakdowns, because in the early days, even the calculators didn't work all that well. But as we've gone along, you guys have lived through an experience, an explosion of different kinds of technologies, both personal technologies over the years, but also technologies that are starting to move off the desktop and into space. Okay, so technologies that can do things like tracking you from location to location, video technologies, photographic technology. I lost my list, but just this variety of new things, digital technologies that begin now to be able to talk to each other, and perhaps the one great thing that technology can really do for us, I think, in classrooms is its immediacy. Is that idea of networking and that ability to interact from technology to technology to get things going. I won't talk a lot about technology failures today. I'm an expert at technology failures. I've generated more technology failures than I can talk about. It's made me very much appreciate the need for always having a backup in the classroom to that technology failure, so that we can not waste everybody's time. But I'm going to talk about it as though they work today, okay, for the most part. And I want to talk a little bit about some of the stuff that I've done and some of the stuff that I'm doing now. So I want to give you a little bit of an idea of the trajectory that I'm going forward with. And as I said, it gets a little bit techy in the end, but hopefully I can motivate the reason for the need for that. I always want to start out a little bit by talking about, let's see, how do I do this? Oh, that should do it. I want to talk first a little bit about my motivation. What I got interested in was the idea, the nature of experiences the kids have, especially in upper elementary and more recently sometimes in middle school classrooms, with respect to the nature of the science that they're able to participate in. There are a lot of different kinds of science, and a lot of different science that works at different time scales. But one of the things that's really tough to pull off in schools is science that happens over very long time scales. And yet, a lot of the science that we do really doesn't happen in the course of that 43-minute period, but happens over the course of weeks or months, or in real science over years. And I always kind of like to start with, I always forget his name too, Karl von Frisch, who was the guy that discovered who came to understand the bee waggle dance, the dance that bees do in the hive to indicate the location of nectar sources outside. Frisch spent about 35 years on this. This became his passion, his life's work, really. And the idea that that he could engage in a single problem that stretched over that was interesting enough and compelling enough for him to stretch over the course of decades was really an exciting thing for me, and was it was the notion of a kind of a science that was so different from anything that we could provide in classrooms. He got a Nobel Prize in 1973 for this work. It wasn't until 2005, in fact, to think about the larger community of science as well, that his theories were confirmed by using actually radar techniques. Some British scientists did that. So the idea of being able to do this in some form in schools was something very appealing to me. But I wanted to do it in classrooms. There's a lot of interest. Allison mentioned that I fell back in love with the classroom, which I did. And the classroom, there's often a deficit view of classrooms. That somehow classrooms offer constraints but no affordances. And classrooms really do have some wonderful things. They have things like a captive audience. That's what we might have here. But that captive audience is also, and there's a richness to it, because that captive audience becomes a community over time. Over the course of a school year or over the course of multiple years in school, kids get to know each other. And those partnerships and their understandings of what their, the kinds of assets that they're in deficit sometimes that their classmates bring, that becomes an important part of the way that they work. Classrooms have the affordance of having a knowledgeable adult who actually knows something about the material that we're going to be talking about, knows something about how to talk to kids, how to teach, how kids learn. That's a great thing to have, all around all the time. Sometimes we spread them pretty thin, but having that adult there is a wonderful thing. They can serve many different kinds of roles, but it's different from the kinds of things that kids can do without having some kind of guidance around. The other thing that's cool about classrooms is the room. Now, you might not think that a box is a very interesting space, okay? And most classrooms are boxes. There's a lot of interest in redesigning classrooms, reinventing classrooms, using space in new ways. But the reality is the installed base is going to be there for a long time. We just, there aren't that many new schools getting built, and the amount of money that's available to reconfigure schools, or even the potential for doing that in terms of the structural constraints in schools, really limits us. But that box can be an exciting box. I like this picture. This is a picture from a classroom that I did some work with, which to me was, a really kind of reflective, and not a very clear picture, but to me very reflective of the richness that the physical environment can bring. Okay, these wonderful teachers, there wasn't an inch left in this classroom that was not festooned with stuff, and it made you happy every time you walked in there to see kids' work products, to see decorations, to see things that were reflective of the curriculum. It was a fabulous thing. The sad story of this classroom is that the fire marshals came along and said you have to remove all of it. Okay? It's all flammable, and we can't do this anymore, which to me is just incredibly disheartening. But that notion that the classroom has these walls that you can put stuff on, it has ceilings you can put stuff on. Floor's a little tough. The custodians don't like you to mess with the floors too much. But apart from that, classrooms have this physical space, and since I was a kid, the arrangement of classrooms has changed dramatically, from those rows to to tables and centers and group-oriented sorts of things, and also fortunately toward generally more movable furniture as well. So I was very interested in thinking about ways that I might be able to provide these long-term, this kind of opportunity to engage in patient science in these kinds of classrooms, and engage kids in investigations really that would span not just minutes but days and weeks and actually months, using the affordances of the classroom to support that in a couple of different ways. And the first way that I wanted to do that was well, I was going to say, another slide. There are lots of ways to do it. I don't claim to have any magic bullet, and I think variety is so critical to classrooms, having different kinds of activity structures over time. And having real things in classrooms can be a wonderful thing. Perkins talked about this term phenomenaria, things that could be in the classroom, that could be subjects, could be objects of inquiry for children. But one of the problems with phenomenaria like these, with physical phenomenaria, is access. 30 kids in one ant farm is a little tough. Besides the issue of maintaining it and making sure that the ants don't escape, or that the gerbils don't escape, or those sorts of things. So technology has the potential to maybe sometimes simplify a little bit access to objects, to objects of inquiry, and to also to regularize them in a way that you might think of as artificial, because they're not entirely real, but sometimes give us affordances in terms of being able to approach topics that would be very much complicated by the nature of reality and the unpredictability of reality, and the way that interacts with the time constraints that teachers have in working with classrooms. So I wanted to try to do something that was not little things around the room, but that perhaps could use the entire room itself as a space. And part of my motivation for that really came out of working in a laboratory at UIC, which was involved with virtual reality. UIC is the home of the Cave, which I don't know if any of you know what a cave is, but you know, it's a room you go into and it's rear projected. And one of the cool things I always thought really compelling about a cave was the notion that multiple people could be co-present in this immersive environment. Okay, just like a good movie, you know. There's something about having company, about experiencing something collectively that really is compelling. And my experience in doing that and seeing people's reaction to that made me think about ways that might be able to do that in classrooms, but in a different and sort of a cheaper way, sort of a low-rent version of virtual realities. So years ago, about 15 years ago, I had this idea to create this technology that I call embedded phenomena. And the idea with embedded phenomena is that you take a classroom, okay, and oh good, it worked. And you drop in this imaginary spatio-temporal phenomena. That characterizes a lot of scientific phenomena, okay? Science is about things that change and things that have location and all that sort of stuff. So it gives me a pretty big space to work. And it's imaginary in that there is no immediate manifestation of that. It really is about us adopting the conceit that we are in this space and that this thing is happening, okay, even if we can't see it right now. It's not that we can't see it at all, but our access to it is constrained. The idea is that it's sort of the blind man and the elephant. You have access to that phenomena at various places, perhaps around the space. Sometimes in fixed locations, like I did in my very early embedded phenomena. More recently, using mobile technologies that allow us to go and interrogate this imaginary phenomena by moving around. But the idea is that it's distributed and that the distribution is intentional. The idea for almost all the embedded phenomena is to try to reconstruct a phenomena from its spatially distributed components. And one of the things that does is it forces, I think, it forces an instructional design which really is focused on collective investigations. And particularly, since we're talking about the whole room, and we're talking about manifestations of an object of inquiry that's very public and very immersive, it's around you all the time, it's something that really requires the contribution of the entire class. And so all of the embedded phenomena applications that I've worked on over the years, really about, and I couldn't even articulate this in the early days of working on this, but you know, my realization over time is it's really about these collective investigations. It's about engaging an entire class, you know, somewhere between, you know, depending on the class, I've worked in many classes, 15 to 35 kids in some kind of a collective investigation of a phenomena over a long period of time. With the, you know, the really interesting challenges of trying to get kids to value and to leverage the work of their peers. I'm not going to talk about that too much today. That's been a subject that's been of great interest to me for the past couple of years, and especially in some work that I've done with my colleague Jim Slata, who's now at Boston College, used to be at the University of Toronto, around knowledge communities and inquiry. But I'll talk more about the tech today a little bit. So the idea is that these portals are location aware in some sense. Where they are matters. Okay, so you don't see the same thing in different places. You got to go over here to see this part of the phenomena. You got to go over there to see that part of the phenomena, and we got to talk to each other to make sure that we put those two pieces together to make some sense of it. The other thing is that at least in elementary schools, and even to some extent in the middle schools that I've worked with, the notion that the representation of these phenomena are persistent. That the phenomenon itself is persistent. It's ongoing. Nature, you know, I kept thinking about the Big Lebowski. Nature abides, you know. Things keep happening whether we're around to attend to it or not. They happen at night when we're home sleeping. They happen during the day. So I always like that idea that things are proceeding apace. The simulations are not something that I can stop and restart again, but just keep going. And that they are accessible even when we're, for instance, doing other things in the classroom. So even if we're reading right now, or we're doing math right now, we do a lot of math in this embedded phenomena. Even if we're engaging in other subjects, those phenomena are still around and are still represented. So different teachers react to this in different ways. Okay, so I try to keep it kind of at a low level and not screaming at people too much. But my surreptitious goal is to steal a little more time for science in the midst of all the other activities the kids are engaged in. Okay, so let me give you a couple of examples of some of the embedded phenomena I've done over the years. The first one is one called roomquake, which imagines that our classroom is an active seismic field, and that over the course of time we're going to experience a number of seismic events. And the affordances, our portals into the phenomena and embedded phenomena are simulated seismographs. It's very simple. Most of the time they sit there looking like flatline noise. We put a little fake noise in there to do it. And every now and then we have an event which is usually signaled, and I'll give you an example in a little bit, which is which is signaled by some noise usually to indicate there's some rumbling going on. And the task of the kids, at least in the early versions of this, was to interpret the seismographs and then to enact trilateration to try to identify the epicenter of the quake within the physical space of the classroom. That's changed quite a bit over the years, and it's become elaborated and I think much more interesting. My focus in the early days was, how do I make the phenomenon, how do I manifest the phenomenon? It's interesting that in the past 10 years at least, my work has not been hardly about that at all, although it's still really fun to build them. It's been much more about thinking about how to make them richer and deeper experiences, and ways to use them, ways to use the phenomenon in fashions I hadn't planned when I first started working with this sort of stuff. I think it's always kind of interesting to see some examples of this in action. I'm continually frustrated at IRB constraints that don't let me to show video, because video is very compelling in terms of these activities and gives you a flavor for what's going on in the class. But I do have release to do it for scientific presentations, so I can show some of the stuff. Okay, I just can't put it on the web anywhere. So let's see. Now, if I can start this video from here, and I think Andrew showed me the magic trick. Let me set this up a little bit. This was actually the first video I ever made. This video is about 10 years old, 12 years old maybe. This is in a 5th grade classroom where kids have been working with Wall College, or with roomquake for some time, and have developed an understanding of what kind of work they need to do when an event occurs. Right now, we're going to, when the scene begins here, they're actually in a video conference with my colleague Debbie Kilb, who is a seismologist who works out at Scripps Institution of Oceanography. Debbie has the coolest office in the world, over at the Scripps Pier with her surfboard in her office. Okay, so she's talking about about her practice, and we set things up so that we would happen to have a quake at the time that she was watching, because she wanted to see what it looked like too. So the way the quakes occurred were asynchronous. Sometimes they occurred during class, sometimes they occurred on weekends at nights. We could scroll back the tape and look at things. But this one we set up during the day. The only time we couldn't do them was during standardized exams. Okay, so we had to watch out for that. Okay, so here's Debbie.
So the San Andreas Fault is dangerous in some areas of California, but some reasons like down here.
So you'll see the kids reacting to it, going on and reading their seismographs, and then doing a process of trilateration to identify the epicenters.
I'll give it this time, and each little space is what's being recorded by the station.
Oh my gosh!
first time I did this, the portals were tiny little handheld displays. So those were the seismographs in the early days. So they're interpreting the graphs right now to determine the distance of the event from each of their stations.
It's 6. No, it's not starting with that one. No, that's a 0. I know. You got to start with that. 6. It's 6. Magnitude 6.
Negotiating interpretation. And this is going on now for multiple sites. So each of those defines a circle, and we're looking for the intersection of multiple circles.
Are we okay now?
And because we couldn't mark the epicenters on the floor, we marked them on the ceiling. And only the teacher was allowed to climb the ladder for safety reasons, but that was the idea with that. It's funny, you know, I did this actually in a local school, the school where my kids went to. This is where I started doing this work. And I still see some of these kids, and they say, "You're the room plate guy." It's pretty wonderful. Oops. Oh, wait. Let's not do that again. See that as usual, I'm talking too much and running too long, so I'm going to go past some of these a little quickly. There was an activity called Aqua Room that we created where we imagined, this was thanks to a suggestion from Don Wink, we were trying to take a look at the way that geoscientists, that's probably not the right word, hydrogeologists determine the location of aquifer flows within you know, under the ground. So we pretended we were a small town that had some aquifers running underneath, and what we did was a series of dye injections. Okay, so they would put in different colored dyes, and then they would hunt around to see where that dye showed up by doing water extractions. They would get samples. We had these little test tubes made up with these little technologies on the end that could read them. They had them walk over to a spectrometer, plug it in to see, you know, what color they had done, and then they went back to create a wall-sized map of this in the classroom. I'm going to show you a video of this as well, but it was, you know, the beginnings of our getting into a little more and more, adding additional layers of technology, and all the pain that went with that at some time. But the idea that it was no more just about these couple of places around the room, but maybe there were some new ways to use technologies in the service of manifesting and working with, engaging with the phenomenon itself. Okay, well, I'll skip the movie to that one to get some other stuff. I'll try to skip the movie for that. Okay, but this was, for instance, the product of their work. So they were trying to make a map that showed the aquifer flow and the direction of the flow and things like that. And a lot of the early embedded phenomena stuff, the products of students' work, were paper and pencil stuff. They were graphs that they would create, or histograms of the magnitude of earthquakes, or maps, or things, or timelines of earthquake when things happen, and things like that. So they were all. What was exciting about them, and I think what worked very well about them, is that they were public representations. They were persistent representations themselves. So the phenomena and the representation of its history both were being reflected in the physical space of classrooms in a way that was kind of unavoidable. And I thought that was part. I used to use the term saturating children in embedded phenomena, or no, lightly marinating them. Embedded phenomena. You know, just with the notion that even if, you know, even kids, and I think we saw this, even kids who were resistant at first, you know, and who, you know, didn't want to engage in stuff. After a while, with everybody doing it and it all around you, it's kind of hard to avoid. So, you know, maybe persistence helps in some ways. But over time, the kinds of work products that kids created and the kinds of little pieces that they had to put together and assemble to get the bigger picture became sometimes larger and larger and larger, and began to challenge our ability to do this with paper and pencil materials. This is a project from something called Helium that, if you guys read that paper, you might know a little bit about. But Helium was about trying to find really a total ordering of planets, of imaginary planets that were floating around, by looking at pairwise transient occlusions. And so we had a lot of things where the blue planet was in front of the green planet, and the blue planet was in front of the orange planet, and the orange planet was in front of the red planet, and each one of these little notes says something like that, or maybe, you know, this was going faster than that one, or something like that. And my poor student Mark Thompson here is, you know, we were just awash in a wall full of little notes. Okay, so this wall full of little notes became very difficult to try to assemble and to, you know, to put together to try to create some kind of a big picture of what was going on. So we increasingly recognized the need for something that would help us, you know, not only represent the phenomenon, but also help kids work with, that would help kids work with the observations and manipulations that they made around these phenomena to create this bigger picture. And that was around the time that I started to do some work with my colleague Jim Slata, whose work had always been about knowledge communities and inquiry and the way that these sorts of things happen and the way that technologies could be used to support that knowledge construction, that community knowledge construction. And so Jim and I started a partnership which continues to this day. It's been about 7 or 8 years now. And it's been a wonderful partnership. We love and hate each other at times, like all good collaborators will do. Okay, but we continue to battle it out and have a great time debating this stuff. And it got me so interested in this problem of the way that knowledge communities can grow, and especially the way that technologies can be used to support them or fail to support them in that activity, because we've been very proficient at both. I'll go to the next one. One of those projects involved an application that's now been through about 6 iterations, and we're in the midst of another one right now. Brenda can tell you all about it. That we call walkology, where we imagined the conceit with walkology is, unbeknownst to us up to this point in the academic year, the walls of our classroom actually are active ecosystems. There's all kinds of bugs and scum and stuff in those walls, okay? And we've never seen it, but now we have portals into it, okay? So I used to take tablet computers and actually paste them to the wall, so it looked really direct. After a while, we wanted to use bigger screens so that more kids could see them and get around them and look at the stuff. So we started to use like iMacs and things like that. And we used to run fake cables from the back of the iMac into the wall. And so it was a camera into the wall. Now we do it with remote cameras. They're very much simpler as technology has increased. But in this work around walkology, which, you know, had the sort of room-quakey idea of, you know, some of these portals and locations in various spaces around the room, we also had, you know, a very rich set of additional tools to support both teaching and learning, and the collection and curation of students' observations and knowledge production around the observations and the interactions that they were doing. And I'm going to show you about a 5-minute video that's kind of hokey, in that it's got kind of a little soundtrack and stuff like that. But I think it gives a good flavor of the nature of the activity and how the activity had changed from the early days of doing something like walkology, which was just, of roomquake, which is just about the phenomena, sort of, just about the quakes, kind of. Oops, except to jump right to the end. All right, you see what I mean? I didn't do this, but one of our graduate students, Rebecca Coburn, now Rebecca Quintana at the University of Toronto, then now at the University of Michigan, put this video together. These were from a couple of These are the bugs going around eating each other. looking at population levels, all this.
And so, head over to one of the habitats.
One of the things that strikes me, by the way, is the nature of the teacher's role as this activity is going on.
You see that? Yeah. Okay, so let's add that as an observation.
Kids are using their tablets to contribute to a digital knowledge base.
Those bugs are lame, Julia. Whoa, what just happened?
So I know you're really excited about the life cycle, so what if we or something?
Let's watch that one there. What's happening?
So this is still life form, then all of a sudden we just saw the blue beetle. I wonder if there are similarities between
hard to
those
see,
habitats because the habitats are really close to each
But
other.
she's bringing
It'd
up
be
your
interesting
art,
if
the
there were
children's
similarities or
notes.
differences. So let's go
So this
habitat
is
2 and
her
see.
looking at students' contributions to that knowledge base.
Observe different things about, say, this potential life cycle. I agreed on last time. Who could put this life cycle into order? And unfortunately, one of the creatures being in a relationship is a little bit different than like turning into another, right?
If there was a major disturbance that affected the population, how would we know if Benjamin's theory is correct, that things are actually moving between the habitats?
Okay, that's probably enough to get the idea. We'll come back to that. What we saw was, all kinds of new representations and new kinds of work being created. One of the things that we found extremely powerful, I'm not going to talk a lot about it today, but is the power of sort of what I call, instant aggregation. The idea that as kids were making contributions to the knowledge base, we were summarizing and feeding those back out to the students. One of the dangers, and one of the big arguments Jim and I have actually about the way that knowledge bases work, digital knowledge bases work, especially for younger kids, is that sometimes I'm tempted to give a talk titled "Cloud Considered Harmful." The cloud that we're all so used to and we love so much as adults can be a very opaque thing for kids. Okay, and the repeated experience that we've had is that it's not hard to ask kids to contribute knowledge to a knowledge store, to a database, but it's damn hard to get them to use it. Okay, easy to put stuff in. If a teacher says you got to do this, you're supposed to be doing that, they're going to do that. Okay, but the idea of recognizing that there's even value in there for them is really important. Why would they even need to use those data in the first place? And being aware of what the potential, what the space, what information might be actually accessible and useful to them. So there are problems both with like the task of querying. Anybody who's used Google has had problems with queries. Kids are better at it, now these days than they used to be some days ago. But Boolean operators, am I asking for an and or an or? Things can become extremely complicated in terms of asking kids to make those queries. So the mechanical task of making the query can be complex, but I think it's more about awareness and about an understanding of the potential of value for doing that that's really getting in the way of things. Jim and I have tried a number of strategies to try to get around that over the years. One is to continue to ask kids to make contributions, but instead of asking them to have to reach into this black box and extract stuff that they need, we become much more interested in pushing it back out at them. Okay, so the idea of taking what they've done, summarizing it, aggregating it, and then making it available publicly so that they don't have to go and ask for it, but it comes back out to them is one of the techniques we've done. We've done other things like trying to make knowledge contributions larger and more consequential. A lot of systems like the Knowledge Forum system out of the University of Toronto, Brighter and Scardomelia's system, kids' contributions, because they're kids, tend to be short little Twitter-like things. I saw this, it's a half a sentence, it's a phrase or something like that. And so you've got a cardinality of things which becomes very large. So search also becomes complicated because the space gets very large. So we've done things like trying to use poster-sized things for kids' contributions so that they spend a little more time thinking about them, they're a little bit more consequential, and they can then be presented, and they're much more visible as they're working on in the classroom. We've also done things more recently in terms of using the space of classrooms, not just for the manifestation of the phenomena, but as a distributed representation of the emergent knowledge. So one of the things we try to do is sort of partition knowledge so that the knowledge about the blue bug is over here, the knowledge about the green bug is over there, the purple scum is over there, and you're actually conducting queries by walking. Okay? If I want to know something about that, I don't have to make a query for this versus that. It's over there, and that's where conversation is about that thing. We've gone overboard with it. We've got a lot of failures to talk about along those, and I won't get into that one today. But that idea of the fact that the cloud itself, the beautiful cloud, can be can have very dark wall around it, and it can be a tough thing to try to reach into and make sense of it, be able to become something that you can really use, and promote a notion that your colleagues' work has value.
Tom, can I just ask you?
Yeah, go ahead.
Is that what Slaughter disagrees with? What's the argument between?
No,
you and
I
Slaughter?
think Slott agrees with all of that. I think he probably has still more faith in queries, okay, and tagging your contributions. This another problem is when you make a contribution to a knowledge base, the extra work of having to categorize that, so that there is a Boolean way to make a search on that after the fact is very difficult. There might be ways around that with technology. People are doing things with automatic language, with natural language processing and analysis of text and things like that. But still, that extra work. A kid has an idea, and then they spit out the idea, and then you ask them to categorize it along 3 dimensions, okay? And who the hell is going to take the time to do that or do it well? None of us would do it either. So there's a lot of upfront work that's needed to make the query after the fact easy to do. And I think we don't disagree with it. We're trying to find a medium place in between. And Jim has been my partner in all of our efforts to use push technologies rather than pull technologies to get information back to kids. And a lot of it isn't even about the content. A lot of it to me is about acknowledgement of participation. Over and over, we've seen that kids love to see their work reflected publicly, and computers can do that in an immediate way that's so powerful. The idea that I just did this, and there it is, okay, and I can point at it, and we've seen, kids are, they make their contributions, they run over to another place to a public display, they say, there, do you see what I said? And this helps them to attend to what other people are saying too. I think it creates water coolers where kids have opportunities to speak to each other. It's about many different things. Hopefully, sometimes about the science or about the science practices that they're engaging in. But it does create that opportunity for discussion. So the rest of my talk is going to be a little demo. And it's going to be a little demo that I hope works. It may or may not work. And it really reflects my view of kind of my role about the kinds of applications that we've been developing over the years, and the way that a computer scientist like myself could maybe make a contribution around that. One of the things I've seen, of course, it's no surprise to any of us, is that curricula can be very brittle, and highly scripted curricula that are expected to be enacted in the same way in multiple contexts is really problematic in my experience. I've never seen, enactment is about adaptation, and it's about making it work for your kids and your class and your context and the particular curricular goals that your district or your school may impose upon you. And I used to think of these things as applications or as curricula. Now I think of them as suites of resources that could be combined in different ways. And by taking that perspective, I've really been taken by that perspective, the notion that these are tools that can be recombined, reorganized in different fashions, and used in different contexts, sometimes not using some things, sometimes using other things, using them in different combinations. So that I began to think of my role as a learning technologist, at least with respect to these kinds of long project-based experiences, as thinking about what some of the elemental pieces might be, without necessarily prescribing precisely the way that they're going to be organized. It's not that I don't do that prescription or think about that organization, because I found that I've been programming a lot the last year and a half, only because my graduate students have graduated. I've been forced to become my own chief programmer, but and I forget where I was going with that.
Your role as a technologist, rethinking your role.
Yeah, rethinking of it as building those. I was going to say I've really become. I spend more time doing curriculum design than I ever imagined I would. I think I do more of that than anything else. But every design is going to be different. I've been thinking a lot about the sort of an intermediary role, between the technologist who designs some of the base pieces, a brainstorming tool, simulation of an earthquake, these sorts of things that can be combined in these different ways, and distinguishing that role maybe from a designer role, which is about how do I take those particular pieces and assemble them, for this class, for this particular curriculum, for this context, and that goal, part of my goal is to get to the point where teachers can adopt some of that role. I don't want to lay it on teachers to do that entirely, but I always want teachers to have the flexibility to at least have that opportunity to serve at that kind of role. But maybe there is a role for another person who assembles these technologies, who is not the programmer, not the developer at the lowest level, but is somebody who thinks about the ways that these pieces can be combined. Talking to teachers, and maybe ambitious teachers who have the time and interest to do it actually themselves, or do pieces of it themselves. This is what I'm actually thinking a lot about right now, is the way that goes together. So I'm going to jump out of the slideshow for a minute and take you to software. Oh God, plug-in failure, of course. So. And this one takes forever to load, so I'll try not to do it that way. But let me give a different example. Let me do this example. So here's a newish version of RoomQuake, and it's a hybrid between the way it used to be and the way I want it to be, so it doesn't quite all mesh up. But I want to start here. I want to start here with the notion of a design. Okay, and on this slide, what I'm showing is over here a collection of resources that programmers have developed. Okay, forget this one for just a second, but the idea in RoomQuake is, you got some kind of a script chart recorder. You got that thing that looks like a seismograph that generates the seismographs. Okay, you need some kind of administration. Somebody's got to say when and where those quakes are going to happen and how the room gets set up, that sort of stuff. This is a tool that allows kids to actually record their reading of the seismogram. Okay, So rather than just, you know, what you saw in those early things, which was just a direct mapping, which was really a very rote mapping between 2 points in a curve and a distance, you know, trying to really get more deep into the kinds of information that's available from the interpretation of the seismograph. This is a tool that allows, that creates an aggregation of multiple readings that kids are creating. This is a tool that you could use, say, for an assessment later on. This is a way of scoring your reading, so that, you know, mostly for you. I really believe in sharing, you know, very little of what I do is information that's just for teachers. I'm not a big fan, especially in elementary, and especially for these kind of activities in elementary, middle school. I'm not a big fan of dashboards, okay? Because I don't think teachers have the bandwidth to deal with a very complex dashboard. So the dashboards I give are like start, stop, and let's switch to another section. Okay, that's kind of the limit that really seems to me that they reasonably have access to. So it's a bunch of collection of resources, and I tend to think then of a particular unit, a particular enactment, okay, as taking this set of resources and thinking about who and when those resources are useful, okay? So I think about things like, in this particular one, you know, and these are designable. These are not set in stone. You can call these things any way you want, but, you know, sort of activity phases. Not necessarily sequential, maybe sequential. It's not intended as a script, but it's about which of these resources might I need during these different phases of activity. So when I'm doing planning, I, you know, don't need to have the strip chart running. Okay, I don't need to have any of that stuff running. When I'm doing my trilateration work, I got to have the strip chart running somewhere, and I've got to have I've got to be able to, you know, to crank the earthquakes up from the get-go. But I'm not doing any of the reading stuff in the early phases, and in fact, the earliest phases, the one you saw of Roomquake on the video, would only ever use these two. Okay, so maybe for a younger class, that's all we do. Okay, use a couple of resources. Maybe we don't use these other resources, so we use them in a different way. If I want to get deeper into P&S waves and the way that they work, then it's really about interpretation of the seismogram. I get more into, you know, having them give detailed readings, argumentation about that, recognition of the shapes of curves, and this aggregation as multiple kids are making readings on the same sorts of phenomena. Very interesting for them to see, in a non-judgmental way, the distribution of other kids' work. They're very interested in seeing, this was my reading, what was your reading. You know, we don't put names on them, although they often are very interested in identifying, you know, what their contribution was at that point. But seeing that sort of distribution, and it being okay to be wrong at those cases. To notice that, you know, you're way off and nobody has to yell at you about it, you see it, okay? And you can go back and say, you know, take another shot at it if you want, those sorts of things. Not only are resources conditioned on activity, but resources are also conditioned on roles. I call them portals here because that makes a little more sense to kids and teachers, I think. But these are really about roles. I think of a collection of software as an ecology with many different entree points, okay? So there are ways that we use the same underlying databases, the same underlying tech. It all is just one thing running together. But, you know, you've got a window into it as the teacher. So you can take, and this gets a little bit into device independence, but you can pick up a device, a tablet, a laptop, a desktop, and say, I want this tablet to serve as a teacher portal. I want this tablet or this thing to serve as a student portal. This, by the way, has a really nice advantage in terms of being able to respond to equipment failure in classrooms, so that you can easily switch from one thing to another. So it's not just that this device is the only one that can do this, but I can make those decisions later. I pick up a device, and then I say, what purpose do I want it to serve? What role is this device going to serve? And the same ecology supports not only the participants, but also the public affordances. Because a lot of what we do is not about my tablet or your tablet. It's about these things that we share, the seismograph, okay, or the other public affordances that are available in the classroom. And it's also a portal that can be used by researchers who are taking a look at the logs of student activity, which comes out of the very same databases. For the developers, for somebody who's managing this, say starting and stopping these are all definable roles. Okay, these are just words that you can change. A couple of them are reserved, but most of them are just things that you can change. So if you want to create a role called bumblebees and and caterpillars, you can do that too. You can define the set of roles, and so the idea is that this system is one that allows you to specify, what resources are available. It's about resource allocation. What resources are available to which portals, which roles during which activities. So it's kind of, there are a lot of people who are interested in talking about making available to kids collections of tools, and there's certainly value to the notion that, give kids a bunch of stuff and let them learn over time which are the tools that they need for particular kinds of purposes. I've seen a lot of, my colleague Elliot Soloway always talked about the Microsoft Word of science education. The idea that, everything's available and you can find your way through and use what you need. My experience with upper elementary, early middle school kids is that this kind of thing allows me to stage the introduction of resources in a nice way. It allows me to also make very late decisions about who gets which resource. The administration, the ability to start a quake, to initiate an earthquake that somebody has to interpret, that's not tied to the teacher. It doesn't have to be tied to the teacher. It would just simply be a matter of saying, in my student portal, I'm going to give students the ability to start that quake. The ability to, who has control, who has access to what information when, whether it's public or private, is all stuff that is computer scientists would call late binding. Okay, we make those decisions very late. We can make those decisions, as we go along. So it's also kind of agnostic with respect to who gets to do what when. Okay, who has access to what kind of information when. And we've used that capability quite a bit over the years. The ability to switch that around and to say that, we're going to take it out of, this person's hand and put it in that person's hand. And I would say most of the time it's taking it out of the hands of the teachers and taking it out of stop making it the responsibility of the teachers and let that responsibility be shared with the entire community. And I think that's been a very powerful thing too. My first question about information, about class behavior, about class performances, about things that we're doing is always, why can't we show it to everybody? Okay. Sometimes you can't, but more often than not you can. You can find ways to do that in ways that are not problematic with respect to kids' egos and their participation in things. So I think my time's about up. I'm not going to show you how this interface actually works and how you can do this sort of stuff and switch these sorts of things around. Oh, maybe I could do one quick demo. Maybe I can start a quake. So let's go into the trilateration phase. I think I've already got this set up. So the trilateration phase, we've got a seismograph. Its resource, the only resource it has is a strip chart. It shows the strip chart. And the teacher has the control, has the admin. So if let's see, I'll start a new window here. So this is the configuration, and eventually some version of this, okay, maybe a simplified version of this is what I want to put in. This is the designer's interface, okay, and maybe something simple like this, a simplified version of this, could eventually be something that teachers could use as a resource too. Let me do this. It'll take me just a second, you guys. So I'm going to create two interfaces. So I'm going to go into two portals. I'm going to pretend that I'm picking up two different machines. One of the machines I'm going to use for my teachers. So I'm going to be, let's see, the activity we're in right now is trilateration. And the portal I want to come in as is as a teacher, whatever my name is here. So here's my configuration stuff. Here's where I can, there's a bunch of stuff I can do here, but I'm going to generate a quake. Clear out some old ones I have there. Hopefully this works. It's worked about half the time today. So the idea is I'm going to generate an earthquake right here. And we're going to imagine that these S1, S2, S3, and 4, these are the seismographs, probably IMAX situated around the room. We've had to measure their location. It's not necessarily easy to do this. Technology may fix that too. Okay? Location tracking may be able to make this easier for teachers. So teacher decides that they want to create a quake. And there are a bunch of activities we do around those, but I'll just stick to the visceral part of this here. And now I'm going to, so the teacher on their tablet, on their Chromebook or something, okay, they sit there and say, I want to start a quake here. And then over in the corner, now over on the, yeah, that was the teacher's portal. Now, if I come over here and I come in as, I select my portal as a seismograph, and let's make me seismograph 1. Okay, so this is what's running on the iMac over in on one wall. Okay, and here's what the teacher is seeing right here. This is the very simplest version. And I'm going to generate a quake of magnitude 4. And I'm going to put it right here. So it's going to take, not too long to get over here. I think these run at about, the PNS waves run about 2 meters per second. Okay, I've had to scale these, obviously. Okay, so if I start this quake over here, generate the quake. Okay, gives you time to get out of the way. Okay, and then over on the wall, and hopefully this has worked about 50%. You'll see this. So you'll see this on seismograph 1, seismograph 2. You'll see a different waveform because it's in a different place at a different distance from the quake. That's the sort of stuff that happens. But again, I could give that control to the kids. I could make the seismograph run on their tablets. I could and make the tablets mobile, so we can move them around to different locations. You can do all those sorts of things. So it's that late binding, the ability to do staged introduction of resources. It's not so much I'm trying to withhold resources from kids, but I'm trying to not overwhelm them with resources that are not particularly useful at that point. So I am not helping them understand how to make choices between resources maybe as well as I could, but maybe I'm helping them in other ways to build on their abilities to work with these sorts of technologies. Okay, I have just one final slide because I truly have a lot of people to thank over the years. This is I think, an incomplete list of graduate students and teachers and colleagues and moral supporters who've been part of this project for the last 12, 13 years. So it's been my great pleasure, and the reason that I'm failing at retirement is that it's still
too much
still
fun.
to quote my favorite song from to quote Billy C. Farlow from Commander Cody and his Lost Planet Airmen, I ain't never had too much fun. Thank you, guys.